Hello. So today we'll continue from where we left. The assignment you can keep trying. I will see in the next class. We'll do it together. So today I will talk about the important concept called vectors. So you all know vector thing already. I explained you, but still some more uh, analogy is required. So so in the from long time it was questionable. It was the matter of question that how to represent documents in machine learning format. So if you know that machine learning is basically computer programs, right? So if you give strings as input, then they don't make much value. So it is always required to have a mathematical representation of numbers, which will give more context to the text. Okay. So until now, people, not until now, means some time ago, people were all creating vectors by asking questions. What do you mean by asking questions? Is um, like how many times this particular word has been repeated in the last four paragraphs, or how many synonyms of this word has been used across documents, or you can have some mm, how many times this word has been repeated in the paragraph. So these are various questions whose answers will be in numbers, right? So if it is question one, is the question one, whatever I asked, and it is number is like three times. Okay. Then the next question two, and it is like four times. Okay. Synonyms are used. Question number three, in paragraph, it is used in each paragraph how many times? Two times. So these are so this is what this is becomes a mathematical representation of the vectors of the text. So it gives some context about the text. It is telling that, okay, it is repeated across the document three times. It is repeated, there are four synonyms of the word used, and it is repeated per paragraph two times. So even if it does not give the entire context of the word or token in our language, but it gives some dimensions to it, right? So a particular word may have lot of dimensions if you have to understand it properly, right? So if you are reading about something, say, and and you hear the word French or Indian or whatever, so in your mind you have millions of dimensions for that word, right? So if something is like Indian, then there can be whatever food they eat, whatever clothes they wear, what are their festivals, what is their country, how is their economy, what is their population. Okay. So there are so many questions that are related to the word Indian. And the answer to all those questions will be in numeric. Okay. And if I put them all together, just like I have put now, it becomes a vector of tuples, right? So, and if these questions are predefined and already known, then I can happily remove the question ID, and just keep the numbers, because I know the first entry is for how many times the word is repeated across documents. So I did not need to put one, two, three. This is implicit. This is understood. Sorry, this is four, and then two. So now our representation become a pure vector, right? So this is a vector representation of a word of three dimensions only, right? Three dimension means not in coordinate geometry dimension. It can be viewed like that also, but you think that there are three questions whose answers are we are collecting. So one word is like this. One word is say 7, 2 and 1, and one word is like 2.9, 4.1 and 2.2. So this, so the third one is very similar to the first one, right? It is 3, it is 2.9, it is 4, it is 4.1, it is 2, it is 2.2. So these two words will be very near to each other. So if I have a three-dimensional system to represent these vectors, so first one is 3, 4. So this is the one, and then 2. So it will be somewhere here. Okay. So this will be the first word. And if I collect the second word, it will be somewhere here, right? So both the words in the vector space are very near to each other, and they have a kind of similarity only based on the questions that we asked. Okay, we asked 3 questions, and based on those 3 questions, there is a similarity among these words. But there is no similarity if we have more questions. We are not sure. There may be, there may not be, but there will means it is not sure that these two words will be close to each other if the questions are changed or the number of questions are increased. Okay, so so the vector is always as good as the questions asked, right? So if we have very relevant and contextual questions, then the vector representation of the word is better. But if we have we don't have just a minute. But if we don't have a good set of questions to be asked about the tokens, then we might not have a very good vector representation. And vector representation, what is the benefit? Now I can push these vectors directly into my models, right? So it is so easy. Now it becomes easy. So let's see how to do these vectors um, in our data science, whatever Gensim library we are using, right? So, so I have a text corpus here. So by now you should be aware about what is a corpus, what is a document, what is a token, what is a dictionary. There should not be any confusion. So, so I'm taking a sample text corpus, which consists of 3, 6, 3, 9 sentences. Okay, so this is also considered as a corpus because uh, it contains 9 documents. Because a document can be a file, a sentence, or a directory, or anything, or Wikipedia page, or anything. So the smallest thing that a document can be thought of as a sentence, because beyond sentence there are words. Words are tokens, not documents, right? So we have 9 documents here, and hence it is a corpus. In this corpus, what we do, you simply first we do pre-process of the corpus. That one you all know. Simple pre-process, D accent we do. Then we see the pre-processed corpus. Okay, this is the pre-processed corpus now. All the lines are divided into their respective words, and then they are kind of like put in a list of lists. So this becomes a corpus. Now we create a dictionary, 41 unique tokens. We have a dictionary. You all know this. And then we have a token ID. Token ID means what is the ID for which word. Okay. So this is the ID, ABC is 0, applications is 1, and all this. So now I want to I have a system like this. So doc to bow, you know, right? Doc to bow. What is this thing? So this one is converts a dictionary into a bag of words, right? What is a bag of word here? The frequency. How many times a particular word has been used across the across the corpus. That is called the dictionary or doc to bow, right? So if you see here, just see here for this, I am here using the text to preprocessed corpus, the same preprocessed corpus which it had. So you see that ABC has is used one, applications is used once. Similarly, all the words mostly are being used one time, right? So we have ordering is used once. So we have a kind of dictionary of the Bao corpus here. Now, why I'm saying this is, what is the frequency of the use of a word in across the corpus is the question. So in these questions, remember, so we have only one dimension in this question. What is in the doc to bow representation, in the bag of word representation, the only question that has been asked is, what is the frequency of use of a particular word across the corpus. So only one question is asked, hence the dimension is also one. So in that, so that's why you see, uh, when I use a new text, this is a new document, right? This is a new sentence. So a sentence is also a document. So in this new sentence, I want to get the vector of this sentence using the bag of words model. So what is the question that I'm asking? How many times human is used across the documents? How many times computer and how many times interaction is used across the corpus? So that makes, that is the question that I have asked. And in here I can directly get that. So it says that human is used once, okay, and computer is used once. So if you see here, human is, sorry, computer is 2, okay, then human is 4. So 2 is used one time, 4 is used another one time. There is no interaction here. So uh, in my dictionary, from where I am getting the vectors representation, I don't have the word any entry for interaction. So interaction will be used 0 times, right? So I'm giving a new document, and I am trying to convert this document into a vector, and I say that this is my new document, and just tell me how many times each of these words is used in the corpus of the previous corpus. So human, okay, human is used one time, computer is used one time, but interaction is not used anytime. So it does only print 2 1 and 4 1. The question is, why not interaction? Why not print interaction as a new ID, like say 41 ID and tell 0, right? We can also have written 2 1 4 1 41 0, whereas 41 is the interaction word. But that is a trick that has been used by the Gensim library to save the space. So this is called a dense vector. Dense vector means whatever vector representation is there, there is a value for it, right? Each has a value 1 and 1. But if something is 0, that is implicitly removed. Because normally what happens in this type of vector representation of words, there are a lot of zeros that will come. This is a small example, that's why you cannot see much. But if it is a bigger example, then you will see a lot of zeros are there. So unnecessarily storing zeros in the memory is not a good thing, because already machine learning is very CPU intensive task. So that's why we use the strategy of removing all the zeros from the vectors and creating a dense vector. When you operate on the vectors, that time it will keep the values, but while storing it, it will try to remove it. So this is a in the direction of saving the space. This is a way that has been used, okay. So now you see, based on my question that how many times each word is used, which is the basis of the doc to bow or bag of words concept, I am able to generate a vector for a new document, which is this one, okay. So another one is TF-IDF. So what is TF-IDF? TF-IDF also I said you, right? So that is the rarity of the word. It increases the value of a word which is more rare, right? So what is this then? This is also another This is also another question. So the previous question of bag of words was how many times a particular word is used across the corpus. The second question is here in TF-IDF is how rare is the word across the corpus, right? So 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 both of them are a protocol. Both of them are a rule, but the rules are different or the questions are different. So I can also generate a vector. So the same, let's take the same text. So human computer interaction, I can take it here also, and I'll see it what is the vector representation of human computer interaction in this. You see, so here also 2 1 and 4 1. Here it is 2 is 0.66, 4 is 0.74. So what is this? This is another vector representation, right? Because the question changed. The first time the question was how many of words are repeated across corpus. Here is how rare is the corpus. So it is telling that it is 66% rare. Which one? Human? Not human. Sorry. Number two is computer. Computer is 66% rare, and human is 74% rare. Right. So this is the another way of representing the representing document as a vector. Okay, we are representing the entire document as a vector. So instead of passing this to the computer now, to the machine learning model now, I can pass this. Okay, I can pass this. So this makes more sense and more, we can do a lot of calculations on this. Okay, so any doubts on vectors which I explained till now?
So there I have a doubt. The TF-IDF and the human computer interaction you calculated, right?
Yeah, can you speak a little louder? Your voice is very low, Shiva.
Yes. Yes, Mr. Right. The TF-IDF that you calculated in the step 87, right? 87 to
Yes,
98.
yes, yes.
Yeah. So that calculation, that inverse frequency is based on the word that human computer interaction or with our original dictionary.
Original dictionary. So in the original dictionary, everything is with the original dictionary. You see the term dictionary here,
Yeah, got it. Got it.
right? So what is dictionary? Dictionary is the protocol. Okay, it says that as per this dictionary, okay, as per this, here also you use dictionary. Here also we use dictionary, but here we use the bag of word model, and here you use the TF-IDF model. That's it. Okay, so only that is the difference. So so this dictionary has to be consistent, otherwise the protocol changes, the question changes. What question you are asking, that one changes. So that's why this is important. Okay, now you will see that doc to bow is here also. Then if TF-ID is a separate model, then why you have doc to bow here? Because TF-ID is a model on top of doc to bow. First we get doc to bag of words, and then from the bag of words you calculate what is the rarity of the word. So that's why bag of words is also required here. Okay, that's the reason it is there. Tanmay and Vikram, doubts?
No, I got it actually.
No, Vishwa.
Okay, great. So now I asked you guys to read a particular topic, lemmatization and stemming. Did you go through that article?
Yes, means stemming I completed. Lemmatization I started, means I did not. But
Okay,
yeah, stemming.
okay, okay. Others?
Yeah, Mr. Right.
Okay. So Vikram, you also went through?
No, Vishwa.
Okay. So that was important for you to
Yeah,
go
but I
through.
read long back. I remember some things.
Oh, you
Not
remember something? Okay, okay. That's good. Somebody dropped or what? Oh, Mr. Pulkit, welcome. Pulkit, can you hear me?
Yeah, I can hear you. I really forgot that today was class.
Class. Oh, okay, okay. No problem. Okay. So So guys, can we do one thing? Can we drop the class here itself? I'm having a very bad back pain actually.
Yeah, no problem. Sir. You can take this.
Others, is it okay? I don't know why so much bad back pain is there. I'm struggling to do the class. It's okay, right? Others,
Yeah, yeah.
Pulkit just joined. Anyways, Pulkit will get a
No problem.
recording for this. The first 30 minutes there is a recording, so I'll get this. Okay, guys. I'm sorry. So I don't know. This very nagging pain is there. So let's join in the next class. And as an assignment, uh, try to create a model using your own questions. Okay, there should be 3 questions that you should ask. Okay, determine the question by yourself. Okay, so 3 questions about the words, like one is frequency, one is rarity, and one also you can tell that how whether it is a noun or not, noun or pronoun or verb, something. I'm just throwing ideas in here. So you create 3 questions. Using those 3 questions, create your own model, like bag of words, like TF-IDF. You can create your own model. Let your model be your name, Tanmay, Pulkit, Shiva, or Vikram. Okay, this is the model. Then create the model as per your rules. Okay, using those rules, then the corpus, you can take any corpus. You can take this corpus also. I'll just copy paste this one in the chat. Okay, so I gave the corpus. Quickly copy this one to some notepad or something. So this is the corpus. According to your 3 rules, create a model. From that model, bring a new, like this is the new human interaction, computer interaction. This is the new document. Get the vector of the new document using your protocol, your model. Is the question clear? Tanmay, Pulkit, you won't know, but after the video you will understand. Tanmay and Vikram, is the question clear? What you have to do?
Can you repeat once more?
Yeah. Can you repeat? Yeah.
Yeah, the question is that like bag of words, in bag of words there is one rule, right? How many times the word is repeated across the corpus? What is the rule for TF-IDF? What is the rarity of the word across the corpus? So these 2 models are based on single question, right? The first question was for how many, what is the frequency? Here it is, what is the rarity? I want you guys to create another model, name that model as your name, and create 3 rules. Instead of single rule, create 3 rules for that model. So it will be a class, Python class. I'm giving you a hint. So and that class and that model will have 3 questions for every word in the corpus. Okay, then create your model. Then get a new document, which is the human computer interaction. This is the new document. As per this your new model, what is the vector for that new document? Got it? Tanmay,
Yes. Yeah.
Vikram?
Yeah, got it. But so 3
So
different ends in the sense that same frequency and
no. You decide. You see, for doc to bow, what was the rule? The rule was how many times each word is used, right?
Yeah.
Then when it gave human computer interaction, it said that human was used one time. Sorry, computer was used one time, human was used one time. Okay. So this gave me the vector.
Yeah.
Now suppose your model, like doc to bow, you have a Vikram model. In that
Okay.
Vikram model, you have 3 questions.
Yeah. Okay. Yeah.
Okay, so then you will tell me this 2, instead of 2 1, it will be something more, 2 1 comma 2 comma 3, something will be there.
Okay.
For each word there will be 3 questions. For each question there will be 3 answers, and all 3 answers will get a tuple. So 2 1, 2 2, 2 3, like this.
Okay. Okay. Got it. Yeah.
Got it?
Yeah.
And so what we'll get, the output is that this one should be the input, and your output should be like one vector like this.
Okay.
But instead of bag of words, it should be your model.
Yeah.
Okay, guys. So finish this, and we will meet again in the class. Okay.
Okay.
Anybody has any questions? Okay. Okay, bye. Thank you, guys. Let's meet again next.